Uh, Good afternoon. Thank you, Prashanta, for waking up the post-lunch session. Hopefully, folks are awake now. So, MIDAS India, Medical Imaging and Information Datasets for India. That's what it stands for. It's a joint initiative of ICMR, the Indian Council of Medical Research, IISc, and ARTPARK. The whole concept is that of a hubs and spoke system, where in a disease-specific way, think of these as thematic hubs, and we bring together data from multiple spokes. So medical institutions could be spokes. One particular medical institution can house a hub, so to say, but the concept of hub truly is virtual. The idea is provide a common set of tools, digital public infrastructure, standards, program management, so that for any given use case X, we can bring together data in a way that actually serves that particular use case, creating topic or use case specific standards, and following those protocols in many places. Right? Now I think we are, including AIIMS Delhi, we are in more than 10 institutions, and that's growing very fast. So I'm going to spend, first I wanted to make sure that folks, as I talk about what constitutes data, what is good data, what's bad data, I just simply wanted to lay out a scope here, right? I tend to do this especially with non-technical audience. Most of you probably don't need it. I'm not talking about Gen AI today. I'm talking about more traditional ML. So this is an analogy I often use. AI is like a stapler that's built using staples. And if you try to use it on staples that it wasn't trained on, things tend to be a bit mangled. And the result, especially in health, can be quite dangerous. Right? And I'm sure a lot of you have seen studies about results not generalizing enough, results from lab not being useful enough on the field, so on and so forth. Right? But more dangerous is just randomly taking data from health services or health operations and trying to use it for any particular purpose without realizing what all pitfalls you'll run into, right? And that's the point of this. How many of you have built any sort of health AI in this room? Quick. How many of you have tried to build any health AI in your labs, in your classes, et cetera, et cetera? I'm guessing that your first starting point was some GitHub dataset generated in some Western country, right? Not really representative of our needs, not really representative of the people or the context or the devices, so on and so forth, right? And that was fundamentally what it is. First, I'll walk you through a definition of what do we mean by AI here. Here, actually, we are talking about an AI-based solution, not AI. Right? What's a solution? If an ASHA worker has to use a certain app, right, in which there is AI embedded, there is an ASHA worker. It has to be part of her workflows and her incentives as part of those systems and programs to actually use that app. And when she uses it, it should work the way your AI can actually work properly, right? So if she takes images that are blurred, well, you either design your AI for images that are blurred, or find a way to design your product to give instant feedback so that she does not take blurred images, right? So it is not only about AI. So the evaluation actually is about the full solution, right? And I'll give you some examples. There's a bunch of actions. AI is easy to do. I say 90% of what decides whether AI has any impact is beyond AI, right? I mean, it's not about moving bits. It's about moving atoms. It's about moving people, physically, metaphorically, for impact in the real world, right? So there are a bunch of actions that have to happen before and after, and only then you get that impact, right? Let's take the example of, let's say, a technician who can take perfect images using modern equipment versus frontline staff taking imperfect images with, old equipment, right? Similarly, the use case, why that image is being taken can also change. It's an assistive thing for a specialist, or is it simply a yes or no recommendation on whether to refer further or not for a field worker, right? And there's this interconnection is essentially what we really care about, and this also came from my past work of having seen many hospitals think that they have mountains of data. They are incredibly possessive about it. The health systems also think that they can do with all this data because it's AI, right? It's like, let's throw something at it and stir it up, something good's going to come out, right? That really hasn't panned out, right? It's like using 225 tons of ore for lithium enough for one electric vehicle, right? That's the world we are in. So to change that, we need to bring data together in a more purposeful manner. And this is nothing new. All R&D actually follows this. You're trying to discover something. In the case of AI, you're trying to discover some new patterns. And when you say developing AI, you're trying to get that AI model to perform reliably, right? And then you deploy it. Before you deploy it, there are various types of validation certifications. It could be regulatory. It could be, what you call implementation research, health technology assessment, whatever name you use, and then ultimately monitoring, right? Because you have to update. You can't, these black box models cannot be deployed once for all and say you're done. This is not a molecular or chemical device that essentially where the fundamental chemistry does not change, right? These are black box models, and you might not actually be capturing all the things that are impacting your output, and hence you need to monitor and update, right? Few things when we thought about how to think about the whole idea was actually, it came from this element of what's called gold standard data set. But what the hell do we even mean by a gold standard, right? So few things I'll call out, right? One of the fundamental principles we laid out is we said purpose impacts data set inclusion exclusion criteria, right? Let's say for any disease X, you're trying to do screening in a general population. Number of positives are going to be very low and mostly early stage. If you are going to try to do something, if you go to a facility, folks already show with symptoms. By the way, TB is a classic example of this, right? Folks show up with symptoms, which means you will have higher number of positives, and they are at an advanced stage. And if you are trying to use the same algorithm in both places, will you get the same sensitivity and specificity? Should you actually use the same algorithm? What's the data set you should use, you should construct to actually build an algorithm for one versus the other, right? I mean, there's active case finding is a classic challenge in TB, right? So the data set required for that is different. And often you have to overrepresent certain classes, right? It's not population representation typically the way we think of from a biostatistics perspective. And this is not something that clinicians often intuitively grasp. So it required us to bring together truly cross-functional interdisciplinary teams to understand this and do this properly. Another example, this whole idea of, often people say, oh, that's dirty data, that's not clean. Well, that's your ivory tower definition, go to hell, right? Because this has to work in the field. And if this is going to work in the field, let's ask what kind of user you're going to have, what kind of setting you're going to have. Is it going to be a user who will use protocols perfectly and do it? Or is it a user, I would say, a class of users where you see high churn, so training becomes very difficult. So you should, as a matter of operation, expect so-called dirty data, right? Similarly, you may have, the latest and greatest equipment here at IISc or at a top-notch hospital, but they are not going to have latest and greatest equipment. Maybe it is digitized X-rays, not even native X-rays, right? We got to give this thought too. Finally, the element of what you call gold standard or medical truth. In some cases, we do have objective truth. It may be, some molecular diagnostics that you use to ground truth. It might be biopsy that experts look at. Some cases, you don't have such a thing, and we have to go through lots of, several experts to confirm that this is what it is, right? The classic case is radiology. But defining these is also important. So what we've done is we've created a set of tools built on leveraging a lot of open source tools that already exist so that data of multiple types can be gathered based on the requirements we lay out for a particular data set given the use case. Versioning of both the requirements and the data sets is a standard feature, because only when we start building these, trying to do some ML on these, do you often realize what more do you need and what you might have to do differently. So that's the standard part, the versioning, right? Consent, privacy is inbuilt into the process, right? Everything actually starts with a consent for the purpose of using this data for research, right? There is ethics committee approvals at the spoke. Pseudonymization, anonymization. Anonymization in one way, pseudonymization is within the hospital when it's going for care or for any sort of internal annotation. There's pseudonymization so that they can track back if there's something wrong with the record. But once we are actually getting into proper annotation, curation, acceptance into the data set, it's one-way anonymization. Data remains in private cloud with the hospital. There is no centralization of data. It's discoverable through the MIDAS platform. Sample data is made available to everyone, and full access is through a request process. In the future roadmap, we are looking at things like confidential compute and federated learning. Right? Data standardization is a huge element of all of this. Often folks come in any image format. We actually convert it to DICOM, and we chose DICOM for certain use cases based on, again, wide consultations. Various types of data, but how do you annotate? A big issue in interoperability and usefulness of health data is folks labeling it whichever way. Someone might say oral cancer, someone might say oral, squamous cell carcinoma, right? Are they same? Are they related? How should the ML treat it, right? So we worked a lot, and we've actually created overarching ontologies fusing various widely used ontologies out there, SNOMED CT, ICD, Ayushman Bharat Digital Mission, WHO, etc. And what we do is when we start one particular disease area or actually use case, we ask whether this ontology is enough, and if required, we build further on top of that ontology. But everyone starts with that standard ontology. That way, actually there's a lot of relationship just in the ontology itself. It will be quite exciting to see what happens as we do some of this stuff. This is essentially the website through which it's midas.iisc.ac.in, through which you can basically find data sets. Oral cancer is the only one that's really extensively done so far. I think between I think we have around 8 hospitals, and under 8 hospitals, we are working through the oral cancer task force. They have been a tremendous resource. So it's not all about prospective. It's also about leveraging data retrospectively. And if you go on the website, what I should call out is you get detailed information. So this is critical metadata. Why was this data set actually, created? Why was this not created? Is this meant for an aircraft wing or a bicycle wheel, right? What is it good for and what is it not good for? Right? These are some just snapshots for you to look at. There's all modalities of data is possible. While we initially started with imaging, it's already clear that we are getting into things like sounds. Folks are interested in genomics. So this is a very, extensible sort of architecture, highly modular. Right? In fact, I would, working with collaborators here at IISc and Biocon Foundation and KLE Dental, we created actually an oral screening app that has gone into the regulatory process. And the whole thing happened in under 1 year because we basically provided the rails to be able to do that. And a lot of the challenge in realizing our promise around AI in health is, do we have the rails? Do we have the digital infrastructure? Do we have the methodology? Do we have shared understanding of the processes, so on and so forth? And that's where we end up spending a lot of our time. Yeah, so with that, 4 seconds to go, I'm done. Thank you.